Hello team, we're looking at example 3. We've got a weather balloon. It's sighted between two observation points. So we've got a balloon and we're going to look at it. One observation point has an angle of elevation to the balloon is 65, and from a second point that's going to be 37.4 kilometers away, the angle of elevation is going to be 43. So let's take a look at this. I've got observation post 1 and I've got observation post 2, and they're both going to be looking at a balloon. I should have saved the B for the balloon. Oh well, W for weather balloon. I'm going to have an angle of elevation looking at that weather balloon. Now remember, you need a horizontal. The ground might as well be the horizontal. So the angle of elevation to that weather balloon is going to be 65 degrees. Then, from my second point, I have an angle of elevation up to the weather balloon, and that's going to be an angle of elevation of 43 degrees. Again, this is my horizontal and angle of elevation coming up to it. The distance between those two observations is 37.4 kilometers. And they would like us to know the distance from each observation point to the balloon. So they would like to know this length and this length. So why don't we call this length AW? Why don't we call this length BW? Okay, well, taking a look at this, I don't know this side length, but I know that angle. I don't know this side length, but I know that angle. I don't know that angle, but I know this side length. So I'm kind of out of luck. I don't have enough information. But if I find something first, then I can go and use the sine law and find out everything I need. If I was able to determine this angle, then I would be able to set up one of the ratios for the sine law. Well, it so happens that angle W is pretty easy to come up with. It's 180 minus 65 minus 43. The reasoning is the angle sum of the triangle theorem. If you want to give a reason, you don't have to, but it's sometimes nice. So 180 minus 65, So 180 minus 65 minus 43, we get an angle of 72 degrees. Why did I write 70? I don't know, but 72. Okay, so that means that this is 72 degrees. So I can go after either one of those that I want next. So for AW, I would say AW over sine of 43, the angle opposite the side length that I want, equals 37.4 over sine of 72. AW will equal sine of 43, 37.4, sine of 72. All that's left is calculator work. 43 sine times 37.4 equals, divided by 72 sine equals, AW equals approximately, round your answer to the nearest tenth, so it's a 1, so it stays as 26.8 kilometers. So that was step 2. Here's step 3 for BW, and I could have done BW first. It wouldn't have hurt anything. Now I can't use Pythagorean theorem here, okay? Don't be trying to use Pythagorean theorem because it's not a right angle triangle. So we need to use the sine law. So I'm going to say that BW divided by sine of 65, and I'm going to use this one again. I'm not going to use this one. I could, but these numbers have been given to me and I know that they haven't been rounded at all. I did do a little bit of rounding on this one. So I'm going to say 37.4 over sine of 72. BW equals sine 65, 37.4 sine of 72. Make sure you're in degrees. If you're not in degrees, you'll get everything wrong. Times 37.4 divided by, and I come up with approximately 35.6. And those are your two answers. Okay, guys, we'll stop there, and I'll give you some homework, and you can practice this. Okay.